In this sample problem, we are asked, what will the mass of 3 and 7/10 of a mole of ammonia gas be? And ammonia is NH3. I'm going to show you how to solve this question in two different ways. First using the formula, and then using unit canceling. First thing we always want to do is we want to write down the information that we've been given. We can see here we've been given a number of moles, 3 and 7/10 of a mole. The variable for moles is N, so N equals 3 and 7/10. We aren't given another number explicitly, but anytime we're given a chemical's formula, we can determine what its molar mass is. So ammonia's formula is NH3. So if I want to figure out what the molar mass, capital M, is, I need to figure out what the individual molar masses of the nitrogen and the 3 hydrogens is. So in order to do that, I'm going to take a look at the periodic table. On the periodic table, nitrogen is on the right-hand side, which means it's in about the middle of this page here. And I see in the top right-hand corner of nitrogen's square that its molar mass is 14 and 1/100th of a gram per mole. So I'm going to start by adding in the nitrogen's molar mass. And I'm going to include the units because I always want to write my units down. Now, next I need to figure out what the molar masses from the hydrogens are. The important thing is that there are 3 hydrogens here. So I'm going to need to find out hydrogen's mass, molar mass, but I'm also going to need to multiply it by 3 to take those 3 atoms into account. Going back to my periodic table, hydrogen's on the left-hand side and it's in the top left-hand corner. Looking at that square, I see that in the top right corner of it, the molar mass of hydrogen is 1 and 1/100th of a gram per mole. So I'm going to write that down as well. Adding all of that together, I can see that in total, I have 17 and 4/100ths of a gram per mole. So that is my molar mass for ammonia. Now, first I'm going to show you how to do this using the formula. The formula I want to use here is big M is equal to little m over n. Now, I've been asked to solve for mass. Mass is little m, and it's measured in grams. So I need to rearrange this formula a little bit. I have n on the bottom. I don't want that, so I need to multiply both sides by n. So moles times molar mass will be equal to mass. That is the formula we need to use. Now I am going to flip that left and right. So I get mass equals moles times molar mass, which is equal to 3 and 7/10 of a mole times 17 and 4/100ths of a gram per mole. You'll notice the way that I'm writing out my molar mass here is I'm actually writing it as a fraction because that's what the per mole means. It's actually a fraction with 17 and 4/100ths of a gram on top and 1 mole on the bottom. If I do the calculations here, 3.7 times 17.04, it gives me 63 and 48/1000ths. I have 3 significant digits because I have 3 digits in this number, which means I'm going to round this to 36.0 grams. And that would be our final answer. Now, I've done this using the formula. There is another way to do it. I can also do it using unit canceling. The numbers are all going to be the same if I unit cancel. So the moles is still the same. The molar mass is still the same. And our unknown is still the same as well. We're looking for an unknown number of grams. But it is more important to write that unknown out when you are doing unit canceling, because that unit of grams is going to be what guides us here. We know that we want a final answer in grams. Where else do I already have grams? I already have grams in my molar mass. And technically, every number is actually a fraction, and so is every unit. So I can represent my final units that I want as a fraction, grams over 1. That means that I want grams to be on the top of whatever fractions I make in my formula. If I look at my units for molar mass, I see that grams are already on top there. So when I start solving for mass, I know that I can start with the 17 400ths of a gram over 1 mole, and I don't need to change anything because the grams are already in the position I want them to be in. They're already on top of a fraction. Now, that does leave me with a problem, though. I don't want moles in my final answer. So I have moles here. I need to get rid of them. Where else do I have moles? I have it in my N. So what I can do here is I can actually unit cancel this. I can write 3 7/10 of a mole, and technically this is a fraction over 1. You don't necessarily need to write it out, but writing it out here helps visualize it. What this does then is this is putting moles both on top and on bottom of the fraction. When we multiply all of this together, we'll get 1 unit of moles on the top and 1 unit of moles on the bottom. What happens when you have the same number on top and bottom? Well, it cancels out to equal 1. And actually, the same thing happens with units. If you put moles over moles, they cancel each other out and eliminate each other from the final answer. So we can get rid of moles in both locations, and the only unit we get left with is our grams right here. And that's good because we want an answer that is in grams. The math here looks the exact same as doing it with the formula. But if you can recognize what units you want in the end and use cancellation to get rid of everything you don't need, you can actually solve this without using the formula in the first place.